will perform a one practical that is COVID analysis. So let me introduce some libraries here. And today we are going to do. We will do certain data analysis on a COVID patients. How many patients are there across the globe or in a for a particular country. Not only that, we also discusses what is the real time scenario of COVID around the world. It also includes the number of the deaths, number of patients right now in the admitted uh, in right now in that particular country. And for this we added these libraries, as in these all are for particular date, time and maths random. I think everybody, you all know about all these libraries. We did three kinds of calculation on the data set. One is we apply a linear regression, another is Bayes theorem, Bayesian rich, and third one is sport vector machine. We also imported sport vector machine. So we do three kinds of analysis with the help of these algorithms. So first of all, let me run this. So once we run this, all the libraries are they get added. It depends upon the internet speed, since it is taking long time. It means, yeah, now all the libraries are included. Now the data set is very important this time. Data set we are taking from the web data. This time we are taking the web data, and you all must have to know the COVID data set is available on this CSEGIS, on this website. You can take it from this getbustercontent.com from there. So this is the data basically, CSEGIS data. So this is a data site from where you can take the data. Let me copy this and show you. See, this is a WHO data basically, which is already present on a, you may find this data, yeah, on this particular official website, World Health Organization. You can find out COVID data dashboard live. And particularly on this dashboard, the data behind is they are getting from this website they are getting. So we are taking the real time data set over here. This is a real time data set of confirmed deaths, recoveries, latest, and US military medical data and Apple mobility. So these are the several data sets from where you can fetch the data. So let me fetch the data first. So once we run this, it is the data from these sites get fetched, and it is stored with this name. Confirmed means confirmed COVID case, DF means data frame, then deaths, recoveries, and latest. So and US data and Apple. So these are the data set. You can see the data with this, like latest data. So if you want to see the latest data, you just have to type the name with the head. When you type head, you will have top 5 datas with you. It is admin to province, state, country, region. Last update, it is updated 16th November at 5:55. And latitude, longitude, confirmed cases, deaths, recovered, active cases, and combine. This is the country name and the incident. So this will include these top indexes: case fertility ratio, incident rate, combined key. With all the so many countries are there. So similarly, if you want to see deaths, so you can just write deaths here, deaths DF. You may have the deaths DS data with you. So deaths DF. Yeah. So once I played this, now you have the deaths DF record since 21 first 2020 means 21st January. So in Afghanistan there is no COVID during that time. So means there is no death due to COVID. So that's why it is shown zero. So as but we progress towards the today's date, you see on 18th of November there are total 1645 deaths counted in Afghanistan, particularly that country. Similarly, if you want to look for another country, you country origin, you can may have this. You can just remove this head if you want to see the whole data set. You just remove it. It will show you, now the data set of all the countries ranging from A to Z. I hope you all understand this. There are total 269 rows. It means 269 countries data is there with their longitude, latitude, and the date when the COVID starts and the deaths. Basically, this is the data for the deaths. Similarly, if you want to see the uh, confirmed recoveries, if you want to see recoveries, so let's see the recovery rate also. You just have to type recoveries dot underscore df. If I clear this, you see this is the recovery rate of particular countries are shown there. Like if we are talking about Zimbabwe, last country, so the recovery rate you see this this percent 8184 persons are recovered till now, till the date 18th of November means the yesterday. This data is updated every day at 5 o'clock. So till 18th of November we have this data set. So now confirm, similarly you can, if you want to see the confirm means the persons who are confirmed COVID positive. So these are in Afghanistan. There are 43,000. 43,851 COVID cases are there. So this how, and there are 70,000 in the third one. Third country is Algeria. So you can see how the confirmed or deaths, or how many recoveries are done in the various countries. Now we can show you this data. We will have our this kind of data with graphical presentation also. Let we'll see. So this is simple. Okay, let me run this also. Confirmed df. Okay, right, and after that, yes, columns. So confirmed df columns means the confirmed df keys. So it will show you the headers of the confirmed df keys. These are the headers. Since there are generally longitude, latitude, and the dates, that's why it is shown here like this. If you want to see the keys of this, particularly on, if you want to see the keys of latest data, so you just have to write here latest data. You can may have I think everybody understand. With this columns names you have these headers comes here. So you have an information regarding the headers with this. So now if you want to see the number of deaths, recoveries, or confirmed, so let us divide, let us select the column confirmed deaths and recoveries. If you want to see the deaths only, so this is a deaths record of the all the countries. Similarly, if you want to see the recoveries or confirmed, you can just type confirms or recoveries. You may have the data set regarding that particular uh, column that you selected. So next one is date, confirmed keys, world case, total deaths, mortality rate. So there are formulas to calculate mortality rates and everything. These formulas are programmed here at the back end, and once you run this you may have the all the data is uploaded, calculated mortality rate, recovery rate, total recovered, all these datas. See, mortality rate is what? Death sum upon confirmed sum. Recovery rate is recovered sum upon uh, confirmed sum. So you can calculate this also, mortality rate and recovery rate. We will see here. Just wait. Let me first of all, this is the only yeah. Now here we are doing testing and splitting, training and testing. We are taking 50% cases. Hence we trained it with we trained or split the data with test size 0.05. That is 5% testing data we are taking, and 95% training set is there. So now first of all we apply a SVM. SVM, you all know, sport vector machine. Once you run that, we fitted the data with SVM, and when you want to predict its MAE and MSC, you can have this. MAE is mean absolute error and mean squared error. Regarding this SVM, you will have these kind of values, and this is the graph. Similarly, if you want to fit it with polynomial regression with the degree 4, you can fit it. Or you may have the Bayesian, you may have linear model fitted. Now we fitted with the linear regression, and this time we have MAE and MSC value this. So you see the difference in SVM. When we did it with SVM, the MSC MAE is this much, and when we did it with linear model, its value is changed. Now now let's plot it with linear regression. This is the graph. This is the graph that you obtained. Now let it be do with the Bayesian. So when we fitted this data set with the Bayesian algorithm, this is this how you will get the mean and the mean absolute error and the mean squared error about Bayesian algorithm. So we tried it with the three basic algorithms. One is linear regression, another one is SVM, and third one is the Bayesian range. And we found that in the Bayesian range, we will find SVM is one of the most important algorithm, because the mean absolute error is least in the case of SVM. It is least in the case of SVM. It means this algorithm is most accurate one, because the mean absolute error is least. In this case it is 1393233. Okay, this is with SVM, and with linear regression it is 26, which is almost double. And with base it is 25, which is also get double. So we can predict from this data set that SVM is one of the best algorithm for the prediction of COVID. Till now, out of these three, it is one of the best algorithm. Now let's explore some graphs. See, once you this is the we are now plotting the graph by worldwide corona cases with moving average dates. You just have to write plot legend. All these graphs are can be taken by with the help of this library that we are using here, uh, matplotlib. So matplotlib with colors and plot, it is responsible for generating all these kind of graphs. So let's discuss this graph once. Yeah, this is the data set of you see, this is the data set of the coronavirus cases over the time, since from since 22nd first, that is the date, 1st January 2020, when it comes to know that coronavirus is going to spread over the across the countries. So from that date to the today's date, 17th of November, you may have this kind of worldwide coronavirus cases, you can see here. And with the moving average also, 7 days moving average also. So it is slightly lesser than the 7 days moving. 7 days moving average means it is a once the 7 days you have a calculation for the 7 days, then we calculate its average and plotted it. So if your data crossed that 7 days moving average, it means it is moving so rapidly. But since it is almost same or in fact lesser than that, so this shows the the moving average. This moving average shows that over a period of time, it is remain same, not more than that. Similarly, coronavirus death over time, if you see worldwide, worldwide deaths, you see from at the initial days since 21st Jan, and about 50 days there is very less deaths due to coronavirus. But as you see after the 50 days to the almost the year, the death rates increased, and this death rates you see the here it is point 2 point 4. It is not point 2 point 4, it is basically 10 raised power 6, so it is in million. So it is in million basically. I hope you understand because the unit is mentioned here. So the next graph, the recovery graph. You see, as the death graph increased, in the same way, the recovery graph is exponentially increased. Means most of the people get affected by the coronavirus, but most of them are recovered soon. So this graph shows the recovery rate. In the same way, this is the active case over the time. See, active case goes on, increases rapidly, and it increases so rapidly because in the month of December, you may say, in the month of November there are so many festivals, and the people become careless. We may say this is the time period when the lockdown is there. So you can see the it is for the world, but you can see it for India also. We will cover it later. So in India or across the world, the increase initially the active cases are increasing not so rapidly. The reason, probably the main reasons for that is the lockdown. But as a lockdown released, you see how exponentially the active cases over the world get increases. So this is one thing. And yeah, when I run this is now this is for plotting. This is all the data is available. We are just plotting it. I will share this file, no problem, you can see it later on. You see this data is very amazing. World daily increases in confirmed recoveries. You see across the world how the recovery rates increases. You already you compared with you can compare it with the initial one, when there are January, February, you may say, in the month of March, and this is the month of the November, and you can see from March to November there is increased in confirmed deaths as the number of deaths increased. Okay, so this shows world daily increase in COVID-19 deaths. Okay, the next graph the next graph shows the world increase in recoveries. You see the recovery rate is also increased. Recovery rate is also increased. So and after that there are certain more graphs where you can see it over a log graph. Yeah, log, this is a presentation of the same thing in the terms of log graph. So log graph is just basically it is a concise way of presenting something. So the millions of things you can present it in the concise graphs. That is what we call log of corona cases over the time. So you may leave this, no problem. Yeah, the same thing is mentioned here. Now the last, very important. Yeah, this is very important for US. See here we selected a US country. That is why the data set of the US is shown here. But you can have Russia, India, Brazil. You can see it for any country you want to see. You just have to name that country over here. You can visualize that country. So still I'm we will plot it for all. Let us plot it for all first. So firstly it is US will give yeah, you see it will take a time because all the countries China, Italy, all the countries now the plots are there. Brazil confirmed case every. So it will take some time because it is going to be plot now all the countries data. You can see in India. Yeah, this is very important because it belongs to us. So let's see India confirmed case. Yeah, from here. This is a history of India confirmed case. Initially, the confirmed rates are very slow, but after 150 days, you see the confirmed case how rapidly it increase. Similarly, this is the India daily increase in confirmed cases. Daily increase in the confirmed cases. This is the graph. Now this shows after a peak, it is gradually decreased. Now again, it moves upward. It means the confirmed cases are now again increases. Similarly, India daily increases death. See this. This graph is again very important. For initially 2 months, since this is a lockdown period, the deaths are in fact the 3 months time, about 90 days. The lockdown is I think for 3 months. During that period, the number of deaths are very less. But once the unlock is opened, you see gradually how it touches the peak, and now the deaths rate again decreases due to the COVID. So this will show that it is a good sign, which shows the COVID over all over the India, the deaths due to the COVID, now it is decreased. And again, a very important thing, recoveries. You see, initially, most of the people are recovered. That and now the recoveries rate also, falls down. Recovery rates falls down means what? Earlier, most of the people are recovered in 2 or 3 4 days. Now the recovery rates decreases. It means the people are uh, more they are prone to the corona, but the recovery rates are slow. Earlier they are recovered within 2 or 3 or 4 days. Now they will took more time. That is why this will show the recovery rate decreases. Yeah, this shows recovery rate decreases, means the people take long time to get recovered. Similarly, now the same kind of information is for all the other countries. So I hope you understand how we can visualize the data, and similarly you can plot this data with some another tools that I mentioned you in earlier algorithms or earlier projects. So you can perform the same kind of analysis over these data set. So I hope you all understand how coronavirus uh, you can apply another algorithms also, because you know how to what are the various other algorithms like random forest you can apply over here. Another classification algorithm you can apply over here for getting a better result. This is something which is very basic, and this is something which is used in beyond behind this algorithm is behind uh, the websites that from where you are getting the data. So this is the only algorithm that is getting behind that. The all the websites are updated on because of these commands running behind that. So now if anybody have any question you may ask me.